Friends, good evening. Welcome back to the sessions. Hope everybody is doing great and hope you're enjoying the learnings. Welcome back to 360 DigiTMG channel. And this week we will be talking about the databases that are basically used for analytics. As part of this 1 week sessions, I would be trying to give you an overview of why databases are used, what is the primary role of databases in the space of analytics. So that's going to be the agenda for our sessions. Now, before I begin, my name is Sharath and I'm one of the directors with Innodatatics. I have overall 17 years of experience in the industry, and I have worked on more than 50 plus projects. My core work area belongs to the implementations and more towards technical designing the architecture and all that. So that's a quick overview and introduction to myself. And I also want to introduce to 360DigiTMG website for you all. This is the website, and we have a lot of learning resources here. Festive season promotions are also going up. You might also want to explore those options. And as I said, there are a lot of learning resources which are freely available for you to assist in your learning. You can come to the mind map and learning resources. This learning resources becomes very pivotal. I'm clicking on here, and there are many learning resources that you can take advantage of. If you have already attended these sessions, then you should be familiar with all these learning resources. And I'm assuming a lot of you people, majority of you have actually taken the advantage of these resources. If you are joining new, then this is the URL, friends, 360digitmg.com. And at the top, you see learning resources. If you click on that, you will be coming to this page where you can see these tablets where you have different modules that you can take advantage. I will be explaining about all these things, but the first one I want you people to take advantage of is this mind map. You can explore this page. Now, when you click on mind map, you'll get a lot of mind maps like this. You can see the drop down. There are a lot of mind maps which help you in learning things much quicker. Whatever is your core work area, whatever is your core interest, you probably can come here, provided that option is provided here. And then try to see the entire concept in a bird's eye view. This is for data science. You can see Python programming fundamentals. This is basically giving you a complete overview of Python fundamentals that are mandatory for you to learn. Similarly, we have R programming fundamentals also. You should be familiar with these fundamental concepts in order to begin your journey into programming arena. All right, so these are different learning resources that you should be taking advantage of. Now, I will jump into the actual agenda, right? Rather than running around the bush, I'll directly go to the point. And as and how the situation arises, I will be using these learning resources for helping you out understand the concepts. Let's begin. So we're talking about data analytics. Now, if you are a student who is visiting us again, right, to the sessions, then you probably have already gone through the previous sessions, which basically talked about analytics. There are a lot of free resources that are available, and all these resources are placed on YouTube channel. You can also go to the YouTube channel directly from the website here. You scroll down. The learning resources is there. If you scroll down, you will be able to see YouTube, LinkedIn, Twitter, and Facebook. If I click on YouTube, it redirects you to 360DigiTMG website, the homepage. You can subscribe to the link and then get the advantage of all the notifications. So we are conducting the databases for analytics sessions starting today, and we will be conducting it for the next 1 week. But as you can see, there are other resources that are available for you to take advantage of, right? There are a lot of learning resources. So if I go to the video section or playlist section, you can try and look at all the previous sessions that we have conducted. All right. So a lot of these videos are there. You can also see playlists. So just recently, a few weeks back, we have conducted our programming for data analytics. These were live sessions. Prior to that, after that, we have conducted business analytics videos. These are business analytics concepts. And today we are starting databases for analytics. Prior to that, we have auto EDA library discussions, data analytics using specifically Microsoft Excel. Likewise, so on and so forth. You can see a lot of videos that are available. All right, so go through them. Now, we are moving into analytics, right? Our programming for data analytics, business analytics, databases of analytics. So our core agenda here is for performing data analytics. So if I have to talk about data analytics, it is basically helping the business owners to understand what has happened, what is happening, what may happen, and what should be done to control the future. What should be done basically is a decision that a decision maker, a senior manager, or a person who is in authority to take a decision should basically be looking into the past, estimate the future, and then strategically come up with a decision. So your analytics helps the decision makers to get some kind of an evidence to ensure that their decisions are putting the business in the right direction. In our previous sessions, business analytics that is, we talked about stages of analytics. Let's see who all remembers the stages of analytics. People who have attended the previous session, I would like to see if you have remembered the concepts that we covered in our previous sessions. So yeah, you might want to answer the question, what are the various stages that we discussed? Who all remember? I'm giving you a hint. We discussed about 4 stages. Okay, let me say. We talked about descriptive analytics. This is where it describes the past, right? We basically perform a bunch of operations to ensure that we summarize the past and explain what happened. Then we have diagnostic analytics. This basically performs root cause to understand why something happened. Then we have predictive analytics. Predictions, it allows us to estimate the future provided we know and why something happened. We know that something happened and we also know why it has happened. Right? So provided this information, we will be able to estimate the future. And once we are familiar with the future and we know what is causing that future, we will be able to take appropriate steps. This is basically the prescription. So we call it as prescriptive analytics. So these are the 4 stages that we discussed in our previous sessions. Whereas these 2 talk about the past and these 2 talk about the future. And we are in the current. So we look into the past, we look into the future, and then get ready to provide evidences for decision makers. This is what analytics is used for. As you can see, we have data sources, right? And then we have intelligence engine, which basically allows us to try and generate some meaningful insights from these various data generating points, right? So we basically have to see how the journey of the data begins and where does it get its value. This entire journey that we are talking about is called as a data pipeline. So basically, we are talking about data getting generated. So it generates at a source. It goes through certain steps. It flows through certain processes. The data I'm talking about, it flows through these intermediate steps. And then at the destination, it gives value. It brings in value. So data will be in its raw format, but it gives value to that business owners. So this journey that we are talking about is the intermediate data cleaning process, reporting processes, right? Machine learning processes all happen here. We call this entire journey as data pipelines. Okay, remember this terminology. It is like a pipeline wherein your data that is getting generated from the business is flowing through, and then it gives you the destination. Data gives the value at the end. Just like how water pipelines have, right? We have water pipelines in our homes and right, offices, etc., where the water flows in that pipelines, and we are consuming the water that is coming in those pipelines, right? So that's basically the synergy here, data pipelines. Now, whenever we talk about data pipelines, as we talk about the source and the destination, this is a very, very simple image that you can see, which is publicly available on Google. You can search for it. You can say data pipeline, and you will see one of these images. Right? Here, the journey of the data is being summarized in this image. It starts at sources. This is where data is accumulated or generated. But data that is generating in different work areas or touch points in the business will be recorded or will be in different forms. So we will have to ensure that we work on that particular data, refine it, arrange it in a specific format so that the consumption of the data becomes easier. We call this flow as ETL pipelines. We are extracting the data, but when you're extracting, you'll not have one source, you'll have multiple sources. Any business you talk about will probably have multiple touch points where the data is getting generated, whether it is internal, whether it is external, whether it is direct or whether it is indirect data sources or indirect touch points to the business, data gets generated. The data that is getting generated will have certain characteristics depending on how it is getting generated, where it is getting generated, and when it is getting generated. Depending on the properties, we will use appropriate softwares to hold that data. But all this data will be in its raw format. Like, for example, any manufacturing sector, if you want to manufacture a product, you need raw material, the crude form of raw material. You accumulate all the raw materials, refine those raw materials, and then process it to get a finished product. That's the flow here, which is explained as ETL. The first letter E stands for extract. People who don't know the full form of ETL pipelines, please focus here. We're talking about extraction. Collect the data from various sources. It could be social media, it could be websites, it could be customer feedback, it could be offline Excel file where you are recording the data, right? So there will be many touch points where the data gets generated. And in all these, the data will be in different formats. So what we're doing, we transform. T stands for transform. This is where you will be doing a lot of manipulation. Data manipulation happens. Cleaning, refining, arranging, organizing. All these steps happen depending on the characteristics of the data. Now, after you bring the entire data into a specific format, in a proper two-dimensional arrangement for your computers to process it, you would basically store all that accumulated data from different sources transformed into a persistent analytical storage software. We call this as OLAP, online analytical purposes. Here we have data lakes or data warehouses. These are nothing but softwares which hold huge amount of data. Now, once the data is stored for analytical purposes, depending on what you're trying to achieve, you can get that required data for processing. This is where you will get results. The consumers would take the data to generate results. So data is getting generated. It goes through certain steps and it will give meaningful insights. Those are the results. All right, so this is basically the flow of data. But there are very, very important insights that you need to understand from this ETL pipelines. If I have to broadly break it up, then you would see sources, you would see destination. Source and destination. So the data is traveling from source to destination, right? It generated at source, traveled to destination. In the process, in this transit, while it is traveling from source to destination, it goes through a bunch of steps, refining steps, which would allow the data to be processed appropriately based on your requirements. That's your transformations. Now, what is this source? Any transaction that is happening in the business is generating a new data point. That data has to be recorded somewhere. Those are nothing but sources. It could be a real-time streaming data source. And there are a bunch of softwares which basically are used here, like Kafka is the logo here, Apache Kafka. Then you have a bunch of APIs that you can create to capture the data and move the data from UI to backend or backend to UI. Then this cylinder symbol, this is important for us. This is called as a database. I'm pretty sure majority of you know the meaning of database, but we will be demystifying it. We will break it up further. Then we will have files. These are the symbol itself shows that it is a file. It could be a text file. It could be an Excel file or a CSV file. And this is big data tool. The elephant's logo is basically a logo for Hadoop, Apache Hadoop, which symbolizes big data platform. So likewise, you'll have different sources, IoT devices, for example. Right? So there are many other sources also. This is where data is getting accumulated to start with when the transactions are happening in the business. Each of it has its own properties, as I explained. So we are going to try and accumulate all the data, clean it, refine it, and store it. Now, our focus is on this area because even today, when we talk about the data sources, the most prominent and majority of the organizations are using the traditional database softwares, which are also called as RDBMS systems. All right, so that's our focus for the sessions. A data source is basically a location where the data that is getting generated or originates is residing. Databases or flat files are nothing but your individual files. There could be cloud platforms, big data platforms, web services, IIoT, sensors, or other RSS feeds, and so on and so forth. But as I mentioned, the most important and most popular platform is the databases. And even for today, right? From the time it originated, it is still being one of the favorites because the solution itself is so robust that you cannot simply replace it. There are different types of databases we will be discussing about. So, what we are basically trying to understand here, what exactly is databases and how it allows people to perform analytics, how it plays crucial role in the entire volume of analytics. So why I need a database software when I have flat files? Files are there, right? You might probably think about it. I used to think before I got into the world of data, before I was getting into job, working for industry, customers, I didn't understand or didn't realize why databases were so important. So I'll basically tell you a story. Imagine you are an owner for some XYZ organization. Okay, there's an organization called XYZ, and you're the owner of it. We'll talk about a retail store because this is the easiest way to imagine. In India, we call this as general or kirana stores, right? That's the typical terminology that we have. Grocery store, basically. Let's say this is a very simple corner retail store, right? On a daily basis, you are running the business. It's a very new grocery store or retail store. So you probably will have a handful of customers. To start with, you will have handful of customers. So let us assume that you will have 10 customers who are regular visitors. Or maybe I will say, as the business grows, maybe you have, after a 1 month duration, you have around 20 regularly visiting customers. Now, is it difficult for you to remember these 20 customers who are regularly visiting you and doing transactions? Think about it. Is it really difficult? Our brains are tuned to recognize. We will be able to remember things. It's just 20 numbers, so not a big deal. In those days, when I was a kid, probably 3 decades ago, right? Or at least 2.5 decades ago, when I used to go to these grocery stores, right? The retail stores, the products that I used to purchase, we used to get a bill, which is a piece of a paper, right? Can you imagine? Probably in your childhood days, you probably can think and imagine there are stores who are not digitalized. They use papers, they write it on paper and give you the bill. Now, probably only your mother or your father could understand, apart from that owner of that particular store. Nobody could understand what does that bill speak about, isn't it? But it was a physical paper and we did not record it anywhere for future purposes. We used to throw it. Now, as the business grows, right, as obviously as humans we evolve, population grows, demand grows, purchasing capability increases, right? Everything grows. So when business grows, the 20 customers can become 100 customers. Now, can you imagine remembering all the 100 customers and what they are purchasing, when they are purchasing? Is it easy? Not really, right? It's not possible. You cannot. Not at all. Now, in order to engage the customers, in order to track your customers so that you understand what they are doing, how they are doing the business or transactions with you, you want to record the data. This is where you got the computers and your, of course, account books came up, but I'm directly jumping into digitalization. So you start using computers as you. Books will not work out, right? Because you'll not be able to use the books for quick processing. From account books, we moved to digitalization computers. This is where you started storing the file, data into a file, but that again, text file would not solve the problem. That is where Excel came into the picture. Okay, so books were there, but books were not digitalized. So from books, we moved to Excel, computers. Now, Excel becomes one of the oldest software to help you organize and arrange the data for processing or for doing some kind of analytics. Okay, so Excel is an awesome tool. Okay, probably everybody uses Excel, right? I'm pretty sure everybody uses Excel. But there are a lot of advanced concepts of Excel which can be used for analytical purposes. Again, we have the videos here which you can go through. Okay, where is this? Let me try and data analytics using Excel. You will be mesmerized. Trust me, you'll be surprised to learn that there are so many features in Excel which are completely new for you. And these features will help you to generate awesome reports in quick time. If you're new to Excel, go there and learn some shortcuts. That would help. Without Excel, you cannot really survive on a computer. Okay, so that's kind of a mandatory product for you. All right, now the Excel was a very good software to manage the data, but it had its own challenges. What are those challenges? Let's say I'm doing the business. I'm the owner of the organization now. Imagine, or you also put yourself in the owner's shoes, right? You're doing this business, or we are doing the business on day-to-day basis, continuously for some time now. Let us imagine the business is running for quite a few years now, and we have data collected in Excel. So we are using computers, we are digitalized already. But the volume of transactions that have increased probably from increase of 100 customers now to 500 customers. So if I have 500 customers, the amount of transactions on daily basis is also going to increase, right? Let's say the retail store has become supermarket. So if I have a supermarket or a superstore, then the number of customers increase, the number of items that I'm selling will be increasing. So the amount of transactions also increase. Now let us imagine on daily basis, we are generating a lot of transactions. Let's say 10,000 transactions, right? Likewise, on daily basis, we are going to record the details in Excel. But Excel has its own limitations, right? It cannot go beyond 1.4 billion transactions. It cannot increase beyond certain limit. So what happens? You decided to organize the data on a very, very simple manner so that it becomes easy for you to track. So you decided, okay, on monthly basis, month-wise, you are recording the file. So I'll have first file January, second file February, March, April, so on and so forth. I'm recording the transactions in an Excel. Let's say we started doing this from 2020. Okay, I'm just taking 2020. So this is 2023. That means 3 years. 36 files are there. All right, now today, I want to look into certain transactions. Let's say there's a customer who's visiting. But for that customer, I want to understand what kind of transactions the customer has done. Let's say you are the customer. You're visiting my store. To engage you, right, and ensure that you get all the items that you require, I am trying to study your purchasing behavior, what you purchase, when you purchase, right, how much you purchase, etc. And for that, I need historical data. The data is stored in Excel files, and I have 36 files. Now, I would be assigning each customer with an ID, right? So let's say there is a customer, some ID is given. Now, what you do is, in order to understand this customer transactions, you have to access and open 36 files. You don't know when the customer purchased, what the customer purchased, right, etc. So you have to look at all the 36 files and then learn about the customer. Can you imagine that? There are 500 different customers, or counting, it's growing. So it's not easy, right? You cannot just open 36 files on your system and be ready when a new customer comes in, you open this screen and then search for all the 36 files and get the data. Practically, it is not viable. This is the specific reason why a specific software was required, which can retrieve, which can return, right? We will say retrieve the information that is required. When I want some information, I need to retrieve that information or return. The software should return that information. When will it return or retrieve? When you ask a question. Right? Question is nothing but query. When you're posting a query to the software should return or give you the information. I don't want to open 36 files. I want all the data to be looked into. That's nothing but your software, friends. So the software is helping you to manage the entire data, right? Now, in order to retrieve this data, in order to get this entire data, you need to basically store this data in an appropriate format, right? So I'm erasing this. So the true purpose of the software is to ensure you organize and help in retrieve the required information in a quick manner. In short, this is helping to manage the data. So it's a software which allows us to manage the data. Hence the name Database Management System. It's a management system, right? It's a software. What is it managing? The entire data that we have on the customer or on that particular business scenario. So it basically stores the data. It creates a base where you accumulate all the data, dump everything. And here we will have a software which allows us to organize and retrieve the required information at a very, very quick manner. This is basically your DBMS logic flows. So database management system is nothing but a software which allows us to organize and search or retrieve the data frames. That's all. But when you're organizing or when you're trying to retrieve the data, you would have to ensure that you get the information at very quick manner, right? So it follows certain standards. It organizes the data by following those standards. That is one way to ensure it maintains those rules which allow us to retrieve the information in a specific fashion to have quick results. All right, so that's basically how the database softwares are defined. And when we talk about database management systems, there are different ways to organize the data. All right, databases, basically different ways are there. You don't have to say that, hey, I have databases means it's only tables, right? There are many ways that you can actually use the the databases to be stored. All right, now when we talk about these DBMS, database management systems, as I said, there are different types of database formats that we can store, right? We'll be discussing about all of it. Okay, but in order to ensure that results are retrieved much faster, it ensures certain standards are maintained, and this is where we basically bring in a concept called as asset properties. You cannot just expect that you dump the data and then bring in the data when it is required, isn't it? It becomes too difficult for managing it if you just dump it. So these rules and regulations that it maintains is something that we will have to understand. And here I'm going to the SQL concepts. In the mind map resources, I click on SQL concepts. So this is the overview of SQL. And I also have databases. So we are discussing this point. A database is a logical, consistent, and organized collection of data. And this basically allows us to access and manage the data, which includes updation or deletion as well. And it ensures that there is some kind of standard rules maintained so that the data will be, I should say, the data integrity rules are maintained. Whatever data is available, that data will speak for business, right? It is a reflection of the business transactions that are happening. So you need to maintain the data which gives you the true meaning. So for that, yes, there are a bunch of properties that you'll have to maintain, which is called as asset properties. All right. And as I mentioned, right, there are different types of databases, and the most important database format is RDBMS, Relational Database Management Systems. All right. Now, what are these asset properties that you'll have to maintain? The full form of asset stands here: atomicity, consistency, isolation, and durability. Together, they ensure that the data integrity is maintained. Okay, in short, that is what is required. Atomicity says that whenever you're performing an action on the software and the system, which basically is nothing but performing operations on the data, either you perform the action or don't perform the action at all, right? So it is the most atomic, the smallest thing that we have. Either you do the transaction or don't do it. It's not like half doing, right? There will be no half doing. And the data will be consistent. So let's say there is an execution. There is some sequence of steps that you want to perform. Data is here. You basically want to perform these sequence of steps on the data, and it takes some time. There will be latency, some time. And then you'll get results. Okay. Now you can see the star becomes star circle. So that means there is some transformation happens, some value changes. But as a customer or a database accessor, you would see this data until the transaction is successfully completed. Once the transaction is successfully completed, then only you will see this. In the interim, whatever the time it takes for this transaction to complete, the intermediate values are not shown to the user. User will see only either this or this. That's all. This is to ensure that there is consistency in the data. And to achieve this, the operation that we are doing is isolated. We take that offline, right? The isolation basically talks about taking the transaction offline so that the intermediate stages are not shown. After the transaction is completed, you cannot go back, right? Once it is done, and it stays like this unless until again it is changed. That is durability. So whatever changes you are made, it's successful. That's all. If you want to go back, you will have to reapply a reverse transaction, right? But it automatically does not go back. It stays like this only. All right. So these are the 4 properties, asset properties. Next, whatever the standards that we are maintaining, right, with respect to your databases. As I mentioned, there are different types of data models that we have. We basically talk about the structure or the arrangement of the data as a data model. It's nothing but how you are organizing your data. All right. Next, when we talk about these data models, again, there are a bunch of different ways, as I mentioned. The most popular data model is RDBMS, right? We call it as relational data model or entity relationship in fact. We also have object database model. We have a hierarchical model, right? We have network model, so on and so forth. There are many different designs that are possible, right? But we are basically looking into this specific format called RDBMS. This RDBMS is basically defining these characteristics. Okay, the way the data is organized is by defining relationships. Hence the name relational database. All right. So when we talk about this relations between what? So you need to understand the terminologies here. When you talk about data being managed by a software, by your computer can only understand 2-dimensional data objects. Okay, the data that has to be in 2-dimensional data structures. This is nothing but your matrix From mathematical standpoint, it is nothing but matrix. From the arrangement, it is called as table, which contains rows and columns. All right, now, what is a table? A table basically is collection of multiple rows. But what is a single row? What is a row? Row is an observation about some real world entity, right? Where there are different characteristics and we are trying to record those characteristics. In simple words, each row is a collection of columns. A column is nothing but a feature or an attribute or a characteristic of an individual observation. For example, if I talk about students, you all are students who are joining this session, right? Students. So I would create a collection of multiple student details in a table format, in a two-dimensional arrangement. If I take one row, I will have one student, but for that one student, I would have many characteristics. These are nothing but columns, like student name, student gender, student age, subjects the student has studied, location, address, so on and so forth. There are many details that I can capture for that particular student, right? So when I try and bring in this information for multiple students, then it becomes a table arrangement. Okay, this is the basic definition. Now, from the terminology perspective, we call a table as an entity. Yeah, it's a real world entity, right? So it's basically expressing a real world entity. This is an example student I explained, right? Now, for every student, you will have a bunch of characteristics. Using those characteristics, you'll be able to identify that entity or student, like the name of the student, gender, etc. Each of this characteristic is called as an attribute. So an entity is nothing but a table. An attribute is nothing but a column of that table. Now, very, very important. We need to try and identify the relation between these entities, right? There should be relationship between the characteristics. So when I have student table, the student table can be having certain characteristics which can help us understand other details which can be categorized entity. For example, the university the student is studying. University or the course or the department becomes another entity. So there will be certain attributes which define certain meaningful information about the individual observation or individual student when we look into these multiple columns which are arranged in two different tables. Right? It's a little confusing thing, right? So I will talk about student table. I will also talk about department table. So in the student table, I'll have all the demographical details, student details. I might also talk about which year the student is studying, which group the student is studying, or department the student is studying. That's all. You'll not have many details, other details. But when I go to the department table, department as an entity, if I consider, then for that department, I'll have department name, head of the department, right? What all content is there for that department? I mean, different aspects or domains that we consider. If it is a university, how many faculty are there in that department? So there are other features that departments will have, which will not be available here in the students table, right? But if I combine these two, then I can make a meaningful information out of two different tables. But how do I define the relation between these two? Right? That is something that we will have to understand here. Now, you'll be able to define that relationship provided you understand the business scenarios. So we are trying to generate relation between two entities. Hence the name entity relationship. Model means a structure that we are defining, and the data gets stored in that particular model. So the relationships that we talk about are of different types of relationships here. It could be a one column to one column relationship, one-to-one relationship, like I talked about course ID, or department ID in the student table. So I'll have one column which talks about department ID. Using this department ID, in the department table, I will be able to get various other details of that particular department. Here it is student information, right? So it doesn't talk about the faculty of that department, department head. All that information will not be here. But what I'm doing, I'm generating some kind of a relationship between these two columns only, one column to one column. I can also generate relation from one column to many columns, or combine multiple columns and generate a relation with one another column in a different entity, or many to many. So this way we can try and define different type of relationships. So this is a software which allows us to manage the data for the entire location, entire organization. Hence, we create a base where data is residing. Hence, it's called as database management system. And the way that we organize the data is by generating relationships between the entities. We call this software arrangement, or this specific software which arranges the data in ER model, as entity relationship model, but the softwares are called as RDBMS softwares. So your RDBMS softwares follow ER structure or ER model. First, you will have to design the entire structure. Okay, you will have to first plan the structure. And when the data is coming in, the data will follow the structure that we define and gets stored into the software. This way, you are having a controlled environment for your data, which allows you to store and organize and retrieve the data at quick sessions, right? I mean, quick manner. So when you have certain questions for the entire business scenario, rather than looking into the data in an random order, in just an unorganized fashion, if you arrange the data in an organized fashion, proper specific standards being maintained, if you organize the data, then it becomes easy to fetch that required data. I mean, a lot of bachelors, youngsters are there here, I'm pretty sure. So you probably yeah, definitely you don't maintain your wardrobe, your cupboards, right? If you are staying with your families, then your parent, your mother definitely would be organizing the stuff, right? That's how you are going to fetch your clothes when it is specifically required to fetch a specific set of clothes. But if you just dump everything, people who stay in hostels away from the families, they might correlate. You would basically have the entire wardrobe randomly, right? Just jumbled. If you want to fetch a specific, let's say, shirt from that wardrobe, specific clothes, right? You'll not be able to find it easy. So you need to define how you want to organize the data first, then start organizing the right content in that fashion so that when you retrieve, when you want that information, it becomes easier. This is the concept of the databases. Without the databases, you cannot have data stored. And if you don't have data stored, there is no analytics that you can perform. All right. So very, very, very important software. Please refer to the resources that are available here. Right. I've talked about Excel being very, very important. So go through the analytics using Excel videos. In order to understand the immediate important concepts, you can also go through business analytics. You have a recent version of data analytics with Excel here. You can also use this video for this set of videos for gaining the knowledge, right? And this gives you an overview of analytics from a business perspective. And yeah, we'll connect tomorrow and further discuss on the asset properties, the ER models, and then we will also try and understand what does the schema means. All right. Now, our team has shared, we have shared a link for subscribing your right YouTube channel, this particular YouTube channel. Do so if you have not subscribed. And we're also going to share a link for attendance. Okay. So you might also want to register your attendance there. Hope you have enjoyed the concept that we have discussed with respect to the databases. And prior to that, we talked about ETL pipelines, right? And we basically talked about why analytics is becoming so important for any business. So that's the journey that we are looking into. I'll see you all tomorrow to discuss more about the database softwares specifically used for analytics. Until then, thank you so much, friends, and take care. Keep enjoying while you're learning. Thank you, friends.